Hello everyone, this is RayPCB, your trusted PCB partner. Today, we will introduce the schematic design process in KICD. The schematic setup in KICD can generally be divided into the 9 steps shown in the diagram. The first step is to create a new schematic. When you create a project in KICD, it comes with a schematic by default. If that's not enough, you can add more, just like this. Next, we can open this schematic. After opening the schematic, let's look at the second step, which is page setup. For page setup, let's take a look at this button. Click it, and the page setup interface will pop up. The first things we need to pay attention to are these two items. The first is the size of the page. By default, it's set to A4. You can decide how many pages to use and which size to choose based on the size and content of your schematic. The default is A4. This one is the orientation landscape or portrait. The default is landscape, which is also the preference for most people. Next is loading the schematic library. In fact, we've already completed this step. In the current system, the library is loaded automatically as soon as you open it, so we can skip this step. That's this step. The next step is to place components. Let's take a look at how to place components. First, click to place a component. Let's do a simple one. We can search here. Let's make a simple LED circuit. We'll start by placing a battery. Select the battery and place it. This is how you place a component. Then we'll continue by placing a resistor. I type RES, and here we have resistors. I'll place a standard resistor and click OK. Next, we'll place an LED. Type LED, and here you'll see various types of LEDs. Since this is just a demonstration circuit, we're not specifying a particular model, so you can choose any one you like. And with that, the fourth step of placing components is complete. Now the fifth step is adjusting the position of the components. Why do we need to adjust them? Because we're going to draw wires in a moment. And with the current positions, like the direction of this LED, which is also reversed, we need to make some adjustments. It's inconvenient to draw vertical lines for the resistor. So what we can do is first right-click to exit the current state and return to the mouse pointer. Then select the resistor. Here you have options to rotate it left or right, or to mirror it. Since resistors are not directional, we can rotate it to any orientation we like, just make it horizontal, and that will make things easier for us. Next, for the LED, since the positive terminal is on our side and we plan for the circuit to go from here and turn over, we need to rotate it 180 degrees, or simply mirror it. After mirroring, we can adjust its position to align it, so the circuit looks as neat and tidy as possible. That completes the fifth step, adjusting the connections. What about the sixth step? The sixth step is wiring. For wiring, we have various types of wires. Here we can select the first option to draw a wire, then connect each pin one by one. As you can see, by default, we use a 90-degree angle for the turns. In the previous episode, we discussed that the wiring can have different angles, but 90 degrees looks more orderly. Then, in sequence, we connect each pin together, and with that, the most basic circuit connection is complete. The circuit is powered by a battery, passes through a resistor, and then goes into the LED. Next, the following step is to label the reference designators. Why do we need to label them? Because, as you can see, the current reference designators are all R with a question mark, D with a question mark, BT with a question mark. For our final schematic and for publication in books, we can't use these placeholder designators. We need to clearly specify the reference number and resistance value for each resistor. So how do we add reference designators? First, click on Tools, then click on Annotate Schematic, right here. Then we can see the options, whether to annotate the entire schematic or just the current sheet. Since we only have one sheet right now, this option doesn't make a difference for us. The third option assigns a reference designator to a specific component. By default, we use the entire schematic, because if there are multiple sheets, duplicate reference designators across different sheets could cause errors. So we stick with the default option of the entire schematic. Next is the order of the reference designators, which we discussed in the previous session as well. It's about whether to go row by row first, then column, or column by column first, then row. We'll still choose the y-axis direction, which means we assign horizontally first, then move down to the next row. Here there's an option to either keep existing annotations or reset them. The difference is, for example, if you've already drawn a lot of your schematic and then made some modifications in the middle, if you delete a few components and add a few new ones, that's where the difference comes in. If you choose to keep existing annotations, the system will only assign numbers to your new components. In this case, the component reference numbers and the order in the schematic might end up being messy. If you choose to reset existing component annotations, it will delete all annotations and then reassign them according to the selected order. The new components you added will be arranged in the middle, so their reference numbers won't be assigned. Next, we click on Annotate. After annotation, we can see that each component has its reference number, and then we can just close it. Since we only have one of each type of component, they are labeled as R1, D1, and BT1. If we make more complex changes later, you'll see that the sorting can become much more complicated. So the annotation is now complete. Alright, the next step is to edit and check for errors. We need to check if there are any mistakes in this schematic. It's a good habit to get into after drawing the schematic. Always run a check to catch any obvious electrical errors. Checking for errors essentially means performing a comprehensive check. Click on Check, select ERC, and then click Run. It will then check for various errors. Because this circuit is very simple, there are no errors or warnings as everything is 0. If there were errors, they would be displayed as errors and warnings. As for warnings, you can pay attention to them and see if they need to be fixed, but errors must be corrected by yourself. And then the final step is printing the output. If you need to present or explain it to others, you can choose to print the output. To print, go to File, then Print, and select the output mode, either black and white or color. Then just click Print and you're done. Alright, that's all for today's content. If you enjoyed this video, please subscribe to our channel for more videos. Thank you everyone